Welcome to anyone watching this video. What it shows is a radio stack that I've built for the A10C to use in DCS. I now have the space available to build my Simpit. So this is the first full panel I've done since the various prototypes earlier in the year. This is a full radio cluster, the first part of which at the top here is the VHF AM. And the UHF, and then finally the VHF FM. In completing this panel, I've now built it into my desk space for the time that I'll be testing it. And then after the tests are complete, I can then put it to one side, ready to build into the actual frame of the Simpit that hopefully I'll be getting to in the next few months. At this point I'm testing the inputs into the simulator. So as you can see, the various dials that I'm turning to check that they respond properly. But also that the data output, which in this case is the frequency showed on the 7-segment displays, that they are also showed correctly as well. All of the inputs are via a keyboard encoder, and anything that's output, which in this case is the frequency display data as shown on the 7-segment displays, that is achieved by using DCS BIOS. So I'd like to say a big shout out and a thank you to FSF Ian, who's a developer of that. It's a fantastic piece of software, really straightforward to use, and it really adds a whole level to the panel to be able to output that data and have it displayed effectively. These are the 7-segment displays in boot mode, which just indicates there's power to it, but it's not receiving the data stream yet. And when we stream that data across via the SOCAT file, you can see that it feeds through and displays the different frequencies. This test is looking at the backlighting in daytime conditions, and even when in a lit room, you can see that the backlighting is strong enough that all the text is illuminated and you can still clearly make out the 7-segment displays. Whenever I build a panel and I want to keep testing it and also improve my understanding of that panel in the sim, exactly how it functions, I create a mission file in the mission editor that's relevant for that panel. So when I did the countermeasures panel, I had certain threats within certain ranges that I could then test the panel in relation to them. For this panel, I have various transmissions being broadcast on different frequencies. So what I can do here now is go for a flight where I can tune into some of those. I tend to find it helpful for it to be a transmission that would run for a period of time, so I can do a greater number of tests on it whilst I'm receiving that. Sometimes I've looked at signal degradation and other factors, but what I'm looking at now is just tuning into a frequency, then saving that as a preset, and then altering the frequency away from the where it's transmitting, but then clicking to the preset mode, checking that is all functioning properly, and then putting it back. When listening to various transmissions, it's always helpful to have something that runs for a period of time and is interesting to listen to whilst I'm doing all of my building. So I like to listen to the podcast by the 476 Virtual Fighter Group, which I've programmed to transmit at 47.6 megahertz on the VHF FM radio. So I'm just tuning into that now and then turn up the volume to see what I receive.
This just kind of works. So yeah, presumably you've had to do kind of a lot of research, not just on the software side of things, but the physicality of these radios and how they work, and so you can implement them as realistically as possible.
I'm now picking a preset.
You had to learn kind of the radio systems in all of these different aircraft, but you had to learn the actual
we'll go with number 2.
Theory behind it. Yeah?
Load that one.
Yeah, I mean that was surprisingly difficult to actually sort of
change to a different frequency, but alter the preset node. We'll pick up the transmission again.
The sort of spec sheet for a few different radios. So the current transmitting radio is based off the.
Funnily enough, in this case, the most recent podcast 476 has done is actually about radios, so it's quite a good one to listen to whilst I was building this panel.
Based off the spec sheet for that. But actually I've reduced it a little bit because that spec sheet basically assumes that it's a perfect world, there's no losses, cables are amazing. But yeah, so I basically reduced it down.
Third-party plugins like the one being mentioned in this podcast, Simple Radio Standalone, are just fantastic. It just means that you can use the panel so much more, and also extra factors like KY58 encryption.
Yeah. Because you basically receive power over a distance, and that ANC, yeah, 164. Yeah. You can pick it up apparently up to minus 101 decibels.
If we take a close look at the backlit panel now when it's pitch black to see how the light's transmitted, what we can see down the very left and right hand sides will not be seen when it's built into the Simpit. I'm definitely happy with the effect of the backlighting, and I think some of the extra engraved lines around the UHF panel look really good. If we take a look under the hood, you can see what is going on underneath. For anyone looking to build a panel like this, I've now added on a fair amount of detail of the construction. After researching and testing a number of components, these are the ones I'll be using in the panel. The way in which I use rotary encoders will be different for this panel than it was for the ILS panel. I found that the system trying to determine which way you're rotating, whether clockwise or anti-clockwise, led to quite some delay in the input. So in this case, it will just be any form of rotation is one input, and to press the button in the head of the switch will be the second, and that way it just enables 2 inputs per switch, one for an increase in frequency and one for a decrease, but those inputs will be instant. In looking at these components for the UHF panel, one that you'll see, which is just on the left there, is the magnet and proximity sensor. Now, I did spend some time looking at this particular proximity sensor because I wanted to be certain that when the magnet came into close proximity but didn't actually touch the sensor, that would be sufficient to complete the circuit. One of the final and most important parts of the construction planning was to think through how I would wire the MAX 7219 boards, which would feed the frequency outputs of displays. So the principle of wiring from the Arduino to the boards is the same as what I use for the ILS panel and also the caution light panel, but the difference really being that rather than one board there's 4, so that utilises pretty much all of the pins on the Arduino. In this case I'm using the Uno, and it also requires this little add-on here, which will be an extra circuit board I'll build, which just allows me to take the 5-volt output from the Arduino and then feed that in parallel to each of these boards. Now, the code that will be uploaded as a sketch onto the Arduino is just shown here to the left. It is effectively the same as the code I use for the ILS panel, but it's just got extra duplication because you've got effectively 4 times the amount of outputs. So if we take a moment to look through that, you've got your typical start to a DCS BIOS sketch, which also includes the LED control library. Details of pin designations just annotated within the code. And then we have the actual code, which is in 4 main segments, 1 segment relating to each of the 4 boards. The first being the code for the VHF AM, that would be this one here. Then the UHF radio, which will be this middle one. Then the VHF FM, this bottom one here. And then we've got the preset stations, which will all be controlled by this final one. And the final part of the sketch is what happens upon initialization of the MAX 7219 board. So that being when you plug it in and power first reaches it, but prior to it receiving the data stream from the SOCAT file. So upon initialization, I've set it to have a brightness of this figure here, and it can go on a scale of up to 15. And you can also set what will be a boot screen. So I just tend to have some reference to the fact it's a panel for an A10C. Once the data streams through to the board, at that point what's displayed on the boot screen will be replaced by the output of the frequencies. In this test, the 4 boards that we're running follow this wiring schematic. At this point, I'm happy that I am able to output from the one Arduino to the 4 different boards. Following the ILS panel that I built, I made the decision that future panels I would want larger segment displays, and I'd also want them to be green so it's more in keeping with the lighting of the A10C. I therefore set out to try to learn everything I could about the MAX 7219 board and fully break down exactly how it worked. And I also wanted to understand the voltage output because this would now be driving bigger segment displays of a different type. So I started to take my first steps in branching out from the board to one of the new green 7-segment displays. After studying the datasheet and experimenting, I'm at a point where I'm able to branch off of the board to the larger displays. In this test, I'm outputting the preset station from the UHF panel and just checking that it does work fully. I am pleased with the green displays and it gives it the look that I was after. This is my final schematic of all of the wiring on the panel in relation to driving the 7-segment displays. So what I want to do is take a good few minutes here to look very closely at how exactly it will be configured. Now what you've got is at the heart of it is the Arduino, just as we looked at before, with the same code that we looked at as well, and it's feeding 4 boards. You've got the first one here, and this whole part of the arrangement will be the VHF AM. The second one, that'll be the UHF. The third board will be the VHF FM. And then this slightly more involved schematic at the bottom is for the fourth board, which feeds into all of the presets. So if we just take a moment here just to zoom in, you can see the Arduino. It would have the USB coming in that would stream the data to it. It would also provide the power to the board that would come out on a 5-volt circuit and be split in parallel by this little circuit here that I'm going to build. The connections from the Arduino to the 3 main designations on each of the 4 boards is the same as before. If we take a moment, we can just see that. So that's board 1, board 2, board 3, and finally board 4. Okay, so let's just have a look at this extra wiring that we've put in here. So on this board here, if I wanted to take the original red 7-segment displays, I could plug them in here and it's job done. Off you go, it's all finished. Because I want to use bigger segment displays and I want them in green, I'm going to set up this wiring arrangement. So what we will have will be the 7-segment displays here, which will be mounted onto a striped copper clad board, and this is what will protrude through the cutout in the fascia, and obviously this panel will then sit behind. Now what I did find with the original board here for the Max 7219 is these headers meant that generally what you plugged in had a very loose connection. That's if you're branching out and you're using something beyond the actual segment display it came with, which is obviously a perfect fit. So the purpose of this additional board here, which will sit on top of this one, will allow these headers to be fed through all of the strips of copper to these ends, and these ends will be headers which are Molex type connectors. So there'll be Molex style connectors here, 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 and here, and here, 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 here. So what it means is when this sits just under the fascia and this sits a layer or 2 lower down beneath the surface of the panel, it will be 4 main groups of wiring which will be entwined together, and each of those will just be clicked in either end for a firm fix. Now the particular 7-segment displays I'm using, the pin arrangement on the rear of them exactly matches the ones I'm replacing, and therefore it's like for like in terms of where the wires are carried over. It's almost like you could take this one here and if it was to fit, just plug it straight in. So the principle of it is very straightforward. What is important to remember from the point of view of programming is that from the point of view of the data sheet, this is digit 1, 2, 3, 4 on the 1, because they come as a unit of a 4-digit 7-segment display, and the same on the other. But from the point of view of the Max 7219 board, it's actually numbered digit 0 through to digit 7. So just to be clear, looking at the data sheet, you'd be thinking it's digit 1 to digit 8 from left to right, but in reality it's digit 0 to digit 7 from right to left, and it is worth bearing that in mind when you are wiring it and then programming. With that one covered and explained, the principle of that one carries across to the UHF. Now the only difference with the UHF is that rather than using 2 4-digit 7-segment displays, I'm using 2 3-digit 7-segment displays because that's all that's needed for that particular one. And it actually has, for the particular 7-segment displays that I got here, the same number of pins, 6 top, 6 bottom, above and below each one, but the pin number 6 on each one of them ultimately has no purpose because there's not that digit to use. And obviously when that's wired in and connected, then it's effectively, rather than digit 0 and digit 4 in the respect of what this chip's thinking, is digit 1, 2, 3, 5, 6, 7, and the above just represents what the data sheet's telling you. For the VHF FM, well, that is exactly identical to the top one that we already looked at. So taking a moment to look at the wiring arrangement I'm going to use here, what I'm planning to do is to create a much larger breakout board, and that breakout board will consist of copper lines, again copper strips, which along the length of it will be purposely broken in the middle. So something conducting at the top here wouldn't be able to reach beyond this point. It's sort of, this output here will feed the copper lines down here, this one will feed these ones down here, this one will feed those above, and that one, the ones above there too. So yeah, I'll break those connectors there. And in this board here, I will have male to male pin headers that will be soldered in to allow it to click, to allow this top board here to click into these connectors, which will put it into place. And the extra pin headers I'm putting in, as you can see here and here and here and here, are simply just an extension of these original ones here. But to keep it organised therefore in the wiring, these 2 pin headers will be dedicated to a single digit, which in this case will be this right hand digit on the first preset board, and the one above that, which is all in purple, will feed into this one here. Now I've gone from right to left because typically the MAX 7219 board, as it outputs, always runs from right to left from its designations of digits of 0 through to 7. So I've kept that consistent throughout. So if we just have a bit of a closer look here at this one, this is the final breakout board for the VHF AM preset, where I've said data sheet. That's saying according to the data sheet, if you were to look at this to understand these pin designations, this is digit 1, this is digit 2. If we zoom in a little bit more, you can see according to the data sheet where these pins can come in, it tells you which particular segments they will feed. Now normally most of them are a matrix in the true sense. Unfortunately, these particular 2-digit 7-segment displays actually have more pins on them than the actual 4-digit ones. So there's only half as many actual segments, but there's half again in the number of pins. And the reason for that is the way they've built this is such that you could have 2 very separate Adrenos, if you like, or microcontrollers separately feeding one display each, whereas others that are matrixed, you couldn't do that. It feeds the whole thing. Well, it does make sense where you can to get one with the fewest pins possible, but to keep this consistent in brand and size and everything else with the others within that range of that company did, that's the only one that unfortunately they did. So it does create some extra work there. But what we can see is for this one, this will represent digit 0, the first one I'm going to use. So we branch off digit 0, that wire comes across from this pin and it goes into pin 2, because digit 2 from the data sheet of this is actually going to be digit 0 in relation to this board. And then each of the segments then feed into that one particular side. I've coloured them all in blue to be clear that it feeds just this side. When that one's all wired in, we then can see that it's exactly the same arrangement with the purple one, but that one is, we're now on from D0, we're looking at D1, so digit 1 comes out, and that actually goes into what is digit 1 according to the data sheet, and again all of the segments are pulled in. So that principle now is duplicated across all of them, where each one will pick or pull rather an individual digit from this board into it, but then it will have to pull in all of the segments for it to work properly, with the exception of the decimal points. They are not needed. This is a CAD-CAM file which I've put together, and I'm now ready to review it to check it's all accurate before taking it over to the CNC machine. If I just zoom in for a moment so we can just have a closer look at the panel. So this portion here represents the VHF AM. And we then move on to the UHF radio. And then finally the VHF FM, which is just a duplication of the AM, so doing the one, the other's identical in all its dimensions and the way it will be put together. So there's quite a few different colours here, which I've put different things in different colours based on certain considerations. So anything in green will be something I'm going to cut out. That'll be to mount all the components through, and then to secure it with screws, so the screw holes. Anything in black is where I'm going to engrave, so that's mostly text. There are some lines. Anything in blue represents components that will sit on top of the panel, actually sit on the fascia. So that could be dials and slight overhangs of the buttons, and also the flap that covers the load button on the UHF panel. Anything in purple will be the rear of the components, so I've accounted for the dimensions of them at the back, so I know that they will fit together and that there's enough room. So if we just have a closer look at the panel, if I take it back to just a blank piece of material. Okay, so we start with just the piece of acrylic, the dimensions of which I've used here: 152mm in width and 550mm in length. They're the dimensions I'm going to go with for this one. So if I account for where I want the different radios to sit, so there'll be the VHF AM, UHF and the VHF FM, and I've left a bit of material which will act as an overhang, so this is where the Thrustmaster HOTAS throttle will slide in and just sort of touch at this point here, so it'll be just distanced far enough away so there's that gap that's needed, but it will run as one continuous surface. And if I then have a look at building up the different parts of the panel, so the first thing we want to be thinking about is where will the components sit. So in go the cutouts for each of them. So if we look, for example, at the VHF AM, we can see one particularly large cutout here which will accommodate the run of 7-segment displays, a smaller cutout which will also have the 7-segment displays for the preset station, a rectangular cutout to house a rocker style switch to cycle through the preset stations, and then a series of the circular holes, which a lot of what's mounted through here are rotary encoders, and in using those, obviously it will let you dial in different frequencies and whatnot. For the UHF, exactly the same type of components to go in there, just obviously a smaller run of 7-segment displays for the main output of the frequency. So at this point we're happy with what we're going to cut where, and just dropping in the screw hole, so we're able to mount that into what will be the frame of the Simpit. If we have a look now at all of the text, so if we jump in again on the VHF, we can see all of the text that you see in the cockpit carried across in a very similar style of font. Now further into the panel, and this is on the UHF radio, there's some very distinctive and backlit lines in the actual cockpit, which run from just under the actual dials up to the display readout, and it's a good touch because it has a horizontal line which just makes it clear which particular part of the display it relates to. So I'm going to engrave these lines here, and what I'm going to have here is a rotary switch. That's why that hole's that little bit bigger, because I've got a series of fixed positions, but these 4 will be rotary encoders, and the dial heads that sit on all of these will, the diameter will be such that it will go slightly over the actual engraved line, so it will look like the illuminated line runs from under it and up to this horizontal expansion, which will be exactly in line with each of these 7-segment displays itself. So when you turn this, say this one here, it'll be controlling exactly the digits above this line here. When I mentioned some of these screw holes being dropped into the panel here and used to secure it within the pit, some of them will also be used to secure the components themselves. So if I just say toggle on and off some of the screw holes, you can see as they appear, like for example this one here and this one here near the edges would be used to secure this into the Simpit, whereas these 2 here will be used to secure the actual component, in this case of the 7-segment displays. So it's a good time to bring in now the rear layer showing all the components that will be mounted at the back of the panel. So having a closer look at that now, we can see on the UHF radio that this purple rectangle here will be the dimensions of a piece of prototype board I will cut, and what will sit on top of that prototype board will be the 7-segment displays that will sit on top, and screws will be dropped through these holes and pass through this prototype board and be secured from the back. So that's what will actually hold it in place. When we look at some of these dimensions as well that we're dealing with here, you really have to be certain that you've left enough room for it to work. So if I say look at this here, this represents the rear of what will be a toggle switch, and this is some engraved text. So if I was to look at the distance, I mean that is literally 0.9 of a millimetre, so that's not even a millimetre in the distance from what would be the outer edge of the back of that toggle switch to the text. So you know, if that came out any further, then the light at the back will be obstructed from properly illuminating the text and it won't look right. But at the same time, from the front, you're not going to, obviously you wouldn't see this, you'd only see the protruding toggle head which comes through this hole. So sometimes it can affect even the decision of what kind of toggles you have, because you need to be certain that from the front it looks right in terms of the distance from the text to the actual toggle itself. Something to be quite careful of is be sure that all these dial heads are going to be the correct size, they're going to look right, but they're not too big that they're interfering with one another. So if I drop those on here, so again, looking at the UHF panel, you can see all of these represent these blue circles, the dial heads, and again, happy that they're the right size, that they look right, but there is enough of a distance between them that I'll be able to rotate and turn them without, as you turn it, your finger bumping into the next dial along. So let's have a look at the preview of all the toolpaths. So it's drawing out for us now a good illustration of how it's actually going to machine. So if we now have a little bit of a close look at the actual material that's previewed, take out some of the waste material so you can better see the cutout. But when we zoom in now, we can see that the text looks clear and that the preset cutout, if you compare that preview on the right to the CAD image on the left, the CAD image shows the green rectangle that's perfectly square in the edges, but the actual preview on the right does show the actual curvature the tool will create in the corners, and that's something we need to think about when machining. Otherwise the 7 segment displays won't fit. So finally we'll look at the preview of the UHF panel. Text looks good and clear. The lines in the middle, they will cut clearly to remove the paint on the acrylic surface, better than it looks in the preview. If we just zoom in and have a look at that, it looks like it's distorted, and it's not. It's simply that what that's showing is the path that the tool will take. So this is the CAD CAM file finished. With the size of this panel, there's a lot more potential for an error to become clear during the machining, and therefore I will actually produce 2 pieces of acrylic so I can cut into one, and if there's anything that doesn't seem quite right, I've got another one as a spare that I can also use. With a small space now available to build my Simpit, I've bought a bulk load of acrylic, so I'll have all of the material to hand. In preparing the acrylic, I sand it with something like a 400 grit sandpaper, and then I'll move on to applying the paint, which will better adhere itself to that surface. First of all, I clean the acrylic and then I sand it, and at which point it will look like this. The shine's taken off and it's coarse. I then spray the acrylic with several coats of primer, followed by several coats of a further black paint. And this is a finished panel now, ready for me to machine. As we begin the machining, we set the XY intersection to the set datum, and then put the Z-axis in place at plus 50mm. And there we go, we're ready to start now. And at this point I would like to say a big shout out to my father-in-law Phil. Thank you very much for allowing me to utilise your CNC. and also thank you very much for all of you answering my endless run of questions about anything to do with electronics and engineering. As can be seen, I tend to start with the engraving of all the lines and then move on to the engraving of the text. This is the Mach 3 software which controls the movement of the cutting tool based on all the coordinates of the XYZ axis. I do have to say that I find everything to do with the CNC machining process absolutely awesome. This is the cutout for the 7-segment displays for the VHF panel. Here we have several further screw holes being put into place. I found brushing away cuttings which attach themselves to the tool is important because sometimes they'll scratch the surface of the paint and that will mark the fascia. So we're fully cut and just need to clean up this piece of work. These are the 2 pieces of acrylic cut shortly after machining. So on the first piece cut to the left, there were 3 things that weren't quite right, leading to me to recut the final one on the right. The 3 things that weren't right, the first was the cutouts for the segment displays and how to deal with the corners. The second was one drill hole had been dropped through some text. And the third was some of the text was cut so small, some of the lettering blurred. The curvature of a corner normally can actually prevent the segment display being mounted. The way to overcome it in the end wasn't the use of these little fillets you see now. It was to do a clean cutout like you see on the right, but using a smaller 15-degree tip and then sanding the edges of the segment display. This was the screw hole unfortunately dropped through some of the lettering that I corrected. The lettering had to be resized because if you look here, some of the lettering like in the A had flecked away, so I just increased it marginally and that gave us a much cleaner line. I'll have 3 clear layers of perspex, so I'm just marking out where to drill the holes so I can feed all the spacers through and put them in place. This is my starting point now, where I can begin to click in all the components. As I start to build my breakout boards, I do a continuity test on each one just to be sure that the outputs are working correctly. This is a 7-segment display circuit board and a breakout board which are connected together via temporary wires. As each of the display components is completed, I wire it all up and run a series of tests just to be certain it's all functioning properly. What we're looking at now is one of the VHF readouts. You may notice that we talked about using 2 4-digit 7-segment displays. which you have to the left and the right of what you're looking at now, but there is also, if you notice, a single digit in the middle, and that is unused. That's put in purely to ensure that the overall spacing between the digits looks right and is consistent with what's in the cockpit. This is the final test of the circuit components built for the UHF readout. We only need 2 3-digit 7-segment displays for this one. These are the final circuits for the preset stations, just being tested to be sure that they output correctly, and the breakout board that was from the Max 7219 board, that all works correctly, because there was a little bit more to that one. And let's just zoom in and have a closer look at these. These are all of the completed and tested radio displays, which are now ready to have a permanent wire input in place. That's a VHF display, and then a UHF display, another VHF display, and then finally the preset displays. These are all of the components at the back of the panel, and at this point I'm just thinking through the wiring arrangements that will be needed. You can see that the breakout boards for the 7-segment displays are temporarily suspended above them with spacers, just whilst we're testing at this point, and they will, a little bit further into the build, be moved a couple of layers back. I'm now turning my attention to all of the components that will form inputs into the simulation, and I've just connected a few initial wires here to run a few tests on one of the rotary switches just before I move on to wire up the larger rear of the panel. I will use shared grounds between a number of runs of switches just to limit the amount of wiring. After connecting all of the wire ends to all of the input components, many of which had to be soldered, we're initially left with a mass of wiring that will obviously need a good tidy. So I'll take the panel a third at a time, starting with the VHF AM. Sometime later, all of the input wiring for the 3 radios is finished. And then it's time to introduce all of the wiring for the segment displays. I do like all of my panels to be modular. There's a lot of times I'll go back and later on change one of the components or make some kind of improvement. There's always a potential that something could go wrong with the panel and I need to do a little bit of maintenance on it. So I do like some extra length of wire to enable me to pull those layers apart and have that flex and stretch between the different layers. With all of the wiring, there's no right or wrong way. The way I do it suits me and works for me. Other people may have other ideas, and it's just a question of trying lots of different arrangements of wiring and going with the one that works for you. This layer of perspex will have the green LEDs mounted on them and then be spaced at a particular distance that I want to get the right cascade of light, and all of the holes you see are so the wires can then pass through that layer down to one further below. And this bit's like the Blackpool illuminations. The lights are about to be switched on, and let's see how it looks. There's certainly no question that that definitely is bright enough to fully light the back, and I do like the idea that I can have it backlit in daylight conditions where you can still see all of the illuminated text. We're at the point now where all of the components are installed and fully wired, and the first layer of perspex is in place, which controls all of the backlighting. The wiring that we have now is in 3 parts, 1 part for each of the 3 radios, and it has all of the wiring for each of those for both inputs and outputs. All input wiring is fed into keystone jacks, and that will enable me to use Ethernet cables to connect the inputs of the panel to the keyboard encoder. As I put these in place, I also check that every one of the buttons and switches mounted is completing full circuits as needed. In this particular test, I'm wanting to look at the proximity sensor, which will be for the flap above the load button on the VHF radio. So let's introduce the magnet within a proximity of the sensor, and let's see if it completes that circuit. And it looks good. Earlier in this video, when we looked at a wiring schematic, I talked about an extra circuit that I'd introduce, which would just take the 5 volt output from the Arduino and allow me to branch off in parallel to the segment displays. This is that basic circuit completed, which can be now used to feed power to all of the displays, which, as you can see here, are in boot mode as I run various other tests. Let's just have a look at the panel now, a bit of a closer look, and see how it's coming along. And you can see that the flap for the VHF radio, that's something we'll need to come to shortly. Everything's online now, and after doing a number of further tests to check it's all working properly, it's then going to be taking all of the final layers and installing the wiring and the Arduino and other bits into those. In fact, if we just take a look at that now, I've put a basic screw terminal board on the Arduino, and you can see me just holding up there the power distributor, which will feed the displays. We then go down to the Max 7219 breakout boards, of which the wiring from there to the back of the segment displays now has the permanent Molex connectors installed. Since my early prototype panels, I've tried lots of different types of wires to connect the panel to the keyboard encoder. I've tried an old style VGA lead, one of the newer thicker VGA style cables. I've even tried a SCART lead just to try lots of different methods of connection, but I have found that the Ethernet style connector is definitely the one I'm going to go forward with, and it's the best one for me to use. After running a number of tests, I've now built a small brace which will sit on top of some foam, which in turn sits on top of the breakout board. The foam is to distribute the pressure of the downward force of when the brace is put in place, but it just ensures that the breakout board is attached firmly to the Max 7219 board. We're reaching the end of the construction now. You can see that the second acrylic layer is now in place with all of the breakout boards, and in turn every one of those has a brace in place to ensure it's firmly held. And if we just move over and take a look at the third and final layer, this holds in place the power distribution board and the Arduino and the keystone jacks. With this third layer of perspex put into place, that effectively completes a build of the panel, with the exception of the flap for the UHF radio. I start by cutting a piece of paper to size and then working out as a cutout what size of a rim is needed to build up several layers within which that magnet for the proximity switch will sit, and it will sit flush. So if you look at a lower angle in from the side of the panel, you wouldn't see the magnet protruding downwards. So I'll make this out of another piece of acrylic, which I'm just cutting into now. The piece of material you can see me cutting now is what will be the top of the flap, and the 4 holes you see, I'm cutting those in such a way to allow a countersunk screw to drop through. The reason for that is when a small piece of laminate with the channel information sits on top, it will sit totally flat. This is a completed piece of material with its 3 different parts. So with these separate parts, I will now look to glue them together and then paint them. I've glued all the layers together and then held them in place firmly with some mini clamps. This is a small tin of model paint that I'm going to use, and this is it after painted and just left to dry. As I had previously mentioned, I wanted to ensure that the screws in the top were countersunk, and that it held the magnet at the rear, and that if you were to look at that from an angle, it would be flush. I can then fit that into place on the UHF panel, and I've printed a scaled image of the channels, which I will cut that out and then I will laminate it. I take the laminated image, cut it out, and then adhese it to the top of the flap. As that finishes that part of the UHF panel, I now run a few small tests just to check that the flap works, and also the load selector button does also, and also just dialing in various other frequencies. Well, that's a panel fully completed now, and it really has been a lot of fun to build this one and to go through all of the steps and to test it and to now ultimately to use it. I hope that the extra detail I've put in around its construction is of some value to people watching.